So if we flip 4 fair coins and we let y be the number of pairs in those 4 flips, what is the PDF of y? So before we jump right into this, let's just think for a moment about the possible values that y can take on. Now you might think that it can take on 0 or 1 or 2, but if you think about this a bit more, maybe write out some possible cases, you'll notice that that's not really true, right? There's not a case where there's 0 pairs. And this is because there can only be 1, 2, 3, or 4 heads. And if there's 2 heads or 4 heads, right, we know there's 2 pairs. Either there's 2 pairs, both heads pairs, or there's 1 pair of heads and 1 pair of tails. But if there's 1 or 3, there's exactly 1 pair. So from there, right, we can just start by calculating, okay, what's the probability that y equals 1 or that there's exactly 1 pair? So that's the same thing as calculating the probability that there's 1 or 3 heads. And notice the word or there, right? So we're going to be adding our 2 probabilities. So the first thing we can do is we can see that in the case of 1 head, there's 4 different positions where we can choose where our head will go, right? So that's 4 choose 1, which comes from our elementary probability rules. And then we can multiply that by the likelihood of getting 1 head and 3 tails, which is just 1/2 to the power of 1 times 1/2 to the power of 3, because those are all independent events. And then for the 4 choose 3 case, right, when we want 3 heads, it's very similar. So the probability that y equals 1 is going to be this sum here, right? Now to be clear, right, our 0.5 on the left is our number of heads, but because this is a fair coin, it could be, we could easily simplify this and just do 0.5 to the power of 4. Now, okay, we know there's either 1 or 2 pairs, right? So our only other value we care about is p, the probability of y equals 2. So from there, right, we just use our complements rule, and we got 1 minus the probability that y equals 1, and it's 50-50. And yeah, done. That wasn't so bad.